Hello students, I am Ramesh, chemistry faculty from Vidya Mandir Metric Higher Secondary School, Uttangare. Last session we may seen the reaction occurs in organic and also we are seeing intermediates. What are the types of intermediate? And you know very well that is free radical and carbocation and carb anion. And in this session, we may say hybridization and shapes of intermediate. Hybridization and shapes of intermediate. And also nucleophile and electrophile and electron movement in organic reaction. So the first one, hybridization and shapes of intermediate. And in organic compound, suppose we are take that is a CH3, CH, double bond C, H, bond C, triple bond CH. Now, how will you identify hybridization in organic molecule? Then each carbon, it is a very simple way. A carbon is surrounded by how many covalent bonds? Then we may identify, then we may easily say that the hybridization. Suppose this carbon is surrounded by 4 covalent bonds, only sigma bond. So it is 4 covalent bond and 4 sigma bond. So here it is a 4. If it is a sigma bond, it is 2, then it is sp. Then 3 sp2 hybridization. 4 then sp3 hybridization. So it is number of sigma bond. Number of sigma bonds. So number of sigma bond is 2 sp, 3 sp2 and 4 sp3. Listen, here it has 4 sigma bond, so that this carbon has sp3 hybridization. Then this carbon here 1 and 1 hydrogen and here carbon. So here the pi bond is not taken as a count, only the sigma bond. So 1, 2, 3. So it is sp2 hybridization. Then here 1 and 2 and 3. So here also it is sp2 hybridized. Now in this carbon here 1 sigma bond and the remaining 2 are pi bond. So 1 sigma bond and here 1 sigma bond, so that it has only 2, so that it is sp hybridization. Now here that is 1 sigma bond and here it is a pi bond and here also pi bond and it is a sigma bond, so that it has 2, so that it is sp hybridization. So by counting number of sigma bond, not a pi bond, it is sigma bond, then we may take that hybridization. Now we may take 3 intermediates. What are 3 intermediates? The one is carbocation, and the second one, that is carb anion, and the third one, it is free radical. So we have taken these 3 intermediates. These are all reactive intermediates. So in this reactive intermediates, what is a hybridization and shape? So first one, we are taking carbocation. Now we are taking carbocation. We are taking an example, that is carbocation. And we are taking the example, it is CH3 plus. It's a carbocation, methyl carbocation. Now we may find the shape and hybridization. And you know that is carbon. Carbon atomic number 6. And its electronic configuration 1s2, 2s2, and 2px1 and 2py1 and 2pz0 in a ground state. So ground state electronic configuration, carbon 1s2, 2s2, 2px1 and 2py1 and 2pz0. Now, if you are taken in that excited state, one of the electron in 2s orbital is moved to 2p orbital. So that it is 1s2 and 2s1, 2px1 and 2py1 and that 2pz1. Now we may take like this, it is 1s2, then it is 2s1 and 2p1, so 1, 1, 1, so 4 unpaired electron. Now it will be going to hybridized. Now in the case of carbocation, now it has only 3 sigma bond, so that it is sp2 hybridization. So these s orbital and 2 p orbital get hybridized, so sp2 hybridization. So this 3 orbital is going to hybridized to get the equal energy orbital. So it is sp2 hybridization. And if it is sp2 hybridization, then it is trigonal planar structure. So here the trigonal planar structure is like this. What is it? Here it is sp2 and here sp2 and here it is sp2. So sp2 hybridized orbital, sp2 and sp2. So 1 electron and 1 electron and 1 electron. So it is a planar structure. After that, what will happen? Here the 2pz orbital is perpendicular. It is a single plane, it is a planar structure, and the perpendicular axis, the 2pz orbital is present. So it is trigonal planar, then it is sp2 hybridization. One of the pz orbital as perpendicular in axis, so that here we are taking sp2 hybridized, and here one sp2 hybridized, and here it is sp2 hybridized, 1 electron, 1 electron and 1 electron. It is in sp2 hybridization. And the pz orbital is in perpendicular. We are taking that. It is a pz orbital. So pz orbital as perpendicular in shape. Now each one unpaired electron in sp2 hybridization is bonded with the hydrogen. So here it is bonded with the hydrogen. So here hydrogen atom, and here it is bonded with the hydrogen, and here it is bonded with the hydrogen atom. So it is carbocation. And if it is carbocation, 1 electron in pz orbital become vacant because 1 electron is removed. 1 electron is removed. So here in carbocation it is sp2 hybridized, and it is a planar structure. Now we are taking that is second one, it is a carbon free radical. So we are taking it is a free radical. So free radical. And in free radical, what is a free radical? We are taking a carbon as 1 electron. So we are taking the excited state of carbon. So carbon 6, and it is 1s2, and it is 1s2, and 2s1. So it is 2s1, and here 2s1, and 2p1. So it is 2p, here 1 and here 1 and here 1. It is 2p3, and it is excited state of carbon. Now in the case of CH3 dot, 1 electron is present. Now it is also here sp2 hybridized. Here it is also sp2 hybridization, and 1 electron is present in that vacant p orbital. If it is carbocation, it is vacant. And if it is a free radical, methyl free radical, then we are taking that here sp2 hybridized, and here sp2 hybridized, and here sp2 hybridized, and a vacant orbital. So it is the vacant orbital, and this vacant orbital contain one electron, so that it is bonded with one of that carbon electron, and here carbon and carbon, and it is bonded with hydrogen, and it is bonded with hydrogen, and it is also bonded with hydrogen. So it is methyl free radical. So methyl free radical and also that methyl carbocation has same structure and shape. It is trigonal planar and sp2 hybridized. Now it is the third one. It is carbanion. Carbanion. And in this carbanion, we are taking the example, it is CH3 minus. And the negative charge denote one electron in excess. Now, we are taking, that is carbon in that excited state, carbon 6, it is 1s2 and 2s1 and 2p3. And here it is 1s2 and 2s1 and 2p3. Now here the electron is filled. Now one electron get excess. So first it will undergo hybridization. It is sp3 hybridization. S orbital and 3p orbital undergo hybridization. So it is sp3 hybridization. Okay. Now, one electron get excess. So we are adding that one electron here. That is CH3 minus. CH3 minus. So in CH3 minus, it is 2 electron, and here it has 1 electron, and here sp3 hybridized orbital, all are equal energy. So 1, 2 and 1 and 1 and 1. So in CH3 minus, 1 electron is in excess. Now what will happen? Here the shape, these are all sp3 hybridized. sp3 hybridized. If it is sp3, then what is the shape? Tetrahedral. Tetrahedral. So that the tetrahedral shape like this, it is sp3 and sp3 and here sp3 and one more sp3 like this. So all are sp3 hybridized orbital. And what happened here? The pair of electron, so that a pair of electron is present here. This pair of electron. Now each one has 1 electron. Here 1 and that 1. Now hydrogen orbital, s orbital is bonded with this one. So it is for hydrogen. And it is for hydrogen. And it is for hydrogen. So it is sp3 hybridized orbital and a pair of electron. This pair of electron, this lone pair and bond pair repulsion occurs, and it will become a pyramidal shape. So it is tetrahedral shape, but it will be converted into pyramidal. What is that? It is a pyramidal shape. So we are getting that pyramidal shape. So carbanion has a pyramidal shape. So carbocation and free radical planar shape and sp2 hybridization, and here carbanion is a pyramidal and sp3 hybridization. Now it is the next concept, nucleophile. Nucleophile. What is nucleophile? And a nucleophile is a group of atom or molecule. It will move or attracted towards the positive sector. So the nucleophiles are defined as it will be attracted it is attracted towards positive center. It is attracted towards positive center. So, it will be attracted towards a positive center. Then it should be a negative. So, it may be negative charge. Negative charged atom or ion, or maybe the nucleophile may be the neutral atom. Neutral atom or molecule. Neutral atom or molecule contain lone pair of electron. Neutral atom or molecule which contains lone pair of electron. Now, and these are all we are taking that the negatively charged nucleophile. Negatively charged nucleophile. And the negatively charged nucleophile, one is, that is chloride. What is that? It is chloride ion, and bromide ion. It is bromide ion, or you take iodide ion, chloride or bromide or iodide, or maybe Cn minus. What is that Cn minus? It is cyanide ion. So here alkoxide ion or CO minus, it is alkoxide ion, or maybe that is hydroxide ion, it is hydroxide ion, or maybe carboxylate ion or COO minus, it is carboxylate ion. So these are all a negatively charged nucleophile. So the negatively charged nucleophile, it is move towards the positive charge. Move towards the positive charge. Now, the neutral atom or molecule which contains lone pair. For example, we may take that is water. And in water, there are lone pairs, 2 lone pair, and it may act as a nucleophile. And the second one, it is alcohol. What is that? Alcohol is also contains oxygen, and it may act as a nucleophile. And the third one, ether. Ether is ROR. It is also act as a nucleophile because which contains oxygen with a lone pair. And also we are taking ammonia, NH3. It has 1 lone pair. And also that it may be NH2, that is amine. It is also may act as a nucleophile. So the nucleophiles are classified. Nucleophiles are classified by 2 types. One is negatively charged nucleophile and neutral nucleophile. Neutral nucleophile. And the nucleophile may act as Lewis bases. So that the third one, the nucleophile may act as Lewis bases. Lewis bases. What do you mean by Lewis bases? Lewis bases are one which donate an electron pair. So these are all the donors of electron. Donors of electron. So donors of electron may act as a Lewis bases. These Lewis bases, all Lewis bases may act as the nucleophile. Now, if you are taking the reaction and these negatively charged are the neutral molecule which contains lone pair is attracted towards the positive center. It is a positive center. Now, the nucleophile, what is that? The nucleophile. So, the nucleophile may attract the positive centers, and where it will be shared a electron and form a covalent bond, and the nucleophile get stable, so that here the carbon is bonded with nucleophile. So a covalent bond is created Covalent bond is created with the carbocation and nucleophile. And here the nucleophile share its electron or donate its negative charge and lone pair, and it will attain that stability. Next, it is electrophile. Electrophile. They are attracted towards negative center. So, the electrophiles are attracted towards the negative center, so that they are electron deficient. And here it may act as all electrophile or act as Lewis acids. What are called as Lewis acids? Electron acceptors are called as Lewis acids. So these are all electrophile. So electrophiles are attracted towards the negative center, so that it may be classified into two types. One is the positive electrophile and neutral molecules. So neutral molecule. So electrophiles are two types. One is positive electrophile and a neutral molecule, because here it will be attracted towards the negative charge, so that it should be a positive. Now positive electrophile, and the positive electrophiles are take NO plus. It is nitrosonium. So nitrosonium ion. And maybe here C plus, it is carbocation, and this X plus, likewise, that is Cl plus and Br plus and I plus. These are all, that is chloronium and bromonium and iodonium ion. And also it is NO2 plus, it is nitronium ion. So these are all positive electrophile. And also it is H plus, it is proton. What is that? A proton. And also it is H3O plus, it is hydronium ion. So these are all the positive electrophile. Now the neutral electrophile. We are taking the neutral electrophile, and the neutral electrophiles are maybe, that is BF3, and all boron groups or compounds are electron deficient, so it may act as the electrophile. And here, that is AlCl3, aluminum chloride, and ferric chloride, FeCl3, and we are take ZnCl2, and all the metals are vacant orbital, so that it may act as a electrophile. So we are taking a electrophile. Electrophiles are two types. One is positive electrophile and a neutral electrophile. Then they are attracted towards the negative ion. Now we may take here a carbanion. Here a carbanion in organic compound. It is attracted by the electrophile. It is attracted by that electrophile. Electrophiles are positive. So the positive ion will move towards the negative atom, and where it will be accepts the electron and become that stable. So it will accept the electron and become that stable. So carbon and make a covalent bond with that electrophile, and electrophile becomes stable. So these are all electrophile and nucleophile. And the next concept, and here the next concept, that is movement of electron. Movement of electrons. Movement of electron in organic compound or organic reaction. And here the movement of electron in organic reactions. Okay. Here the organic reactions may be understood by taking the movement or displacement of electron. Movement or displacement of electron. So here the organic reactions can be understood by following electron displacement. So organic reactions can be understood by electron displacement, and this electron displacement depends nature of one, it is a substrate, and nature of reagent, and that is reaction condition. So condition of the reaction. So electron movement or displacement, that will be depend on these three factors. One is a substrate and a reagent and the condition of the reaction. And we are taking this electron displacement sometimes occur the movement of bond and breaking of a bond and the formation of a new bond. Now, according to this electron displacement, we are categorized into three types. And the one is lone pair becomes bond pair. So the first one, it is lone pair becomes bond pair. And here the lone pair may be converted into bond pair. Listen, here we are taking, that is hydrogen and OH minus. Now there is a lone pair and it is attracted by that H plus ion, and this H plus ion, the lone pair will be moved and making that the bond pair oxygen and oxygen. So water molecule is formed. So here what will happen? The lone pair become the bond pair. So lone pair become bond pair. Next example, the lone pair become or converted into bond pair, and here we are taking, that is a CH2 bond, and it is a positive charge and it is oxygen, and it has lone pair and a negative charge. Now the bond pair, the lone pair become the bond pair. So the lone pair is moved here, then it is converted into, that is bond pair. So oxygen, the two lone pair, and here it is converted into a pi bond, and here carbon, and here hydrogen, and here hydrogen. So the positive charge which is neutralized here, and it is nothing but CH2O, that is formaldehyde molecule. So the next electron displacement is the reverse one, bond pair become lone pair. That is, bond pair is converted into lone pair. Now we are taking a water molecule HO and that H. There is two lone pair. And the bond pair is cleaved and it will be taken off by highest electronegative oxygen atom and become that HO minus. And the negative charge is denoted like this, the lone pair. And with that, H plus. And hydrogen is a loser and oxygen is a gainer. So these bond pair become a lone pair because of highest electronegative oxygen. Now, one more example, we are taking the same one, that is carbon and double bond O and hydrogen, and here hydrogen and oxygen as lone pair. Now, this bond pair, it is one is a sigma bond, another one pi bond. Among these, which one is the weakest bond? The pi bond. So the movement of pi bond towards highest electronegative oxygen atom. Then it is converted into, it is a CH2 plus and that O minus. And here we are taking 3 lone pairs. So it is negative charge is denoted by a lone pair. So the bond pair may be converted into lone pair here. So the next one bond pair is converted into another one bond pair. So the third one, that is bond pair becomes another bond pair. So one bond pair is converted into another one bond pair. For that, we are taking the first example, that is allyl carbocation. Allyl carbocation. And allyl carbocation, what is it allyl carbocation? We are taking like this the bond line formula. It is nothing but allyl carbocation, and here it is a CH2 plus allyl carbocation. And this bond pair, we are taking that here it is a CH2 double bond CH, and here it is a CH2 plus, is nothing but the same one. Now this bond pair, the pi bond will move towards that here. The pi bond will move towards here. So that it will be become, what is that? Here CH2 and this CH2 is moved here. So we are getting that this one, it is CH. So here there is a positive charge. So here there is a positive charge. So allyl carbocation, one bond pair is converted into another one bond pair. Now the second example we are taking, that is ethyl carbocation. We are taking ethyl carbocation, that is CH3 bond CH2 plus ethyl carbocation. And in this ethyl carbocation, it is equivalent to, that is CH, and here H and H, and here that is CH, and here H and this one. Now this bond pair is moved here to compensate the positive charge. So what will happen? It is converted into, that is double bond and the hydrogen bond is removed. So what is it? Here carbon, hydrogen and that hydrogen, and making a double bond and hydrogen and become that positive charge. So what will happen here? One bond pair is converted into another one bond pair. One bond pair is converted into another one bond pair. Then the reverse also, we may take the reverse one. What is that? Here CH2 and double bond CH2. When it is reacted with the proton. It is reacted with the proton. Then here the bond pair is converted. The bond pair is donated to H plus ion and making that is a CH2 plus, and it is a single bond CH3. So the bond pair making one new bond pair. So there are three types of electron movement. One is lone pair become bond pair, and the second one, bond pair become lone pair, and the third one bond pair is converted into another one bond pair. Okay, and students, this session we are taking that the hybridization and the shapes of intermediate, and the second concept, it is nucleophile, and the third concept, electrophile, and the fourth concept, it is movement of electron in organic reactions. Thank you.